Hello, all. Welcome to my YouTube channel. It's me, Javindra Fodil, a structural engineer from Nepal. Today, I'm going to model the building structure in Midas Gen. Due to the user-friendly and easy working interface, its popularity or the use of Midas Gen is increasing day by day in the global scenario. It is based on finite element analysis and used for the analysis and designs of RCC structure, steel, and the composite structure as well. All the structural elements like beam, columns, slabs, shear walls, etc., can be analyzed and designed in this Midas chain. Finally, I would like to thank Midas India for their technical support. And now, let me go to the Midas Windows working interface. We see here this is the Midas Gen 2024 version working interface or Midas window. There are lots of menu like view, structure, node elements, properties menu, boundary, load, analysis, results, pushover, design, seismic performance, query, as well as tool menu. And we see the tree menu here. For example, node, element, boundary, mass, load, and we see the lots of tools or shortcut commands in the top portion as well as right portion of this working interface, and we can active the tree menu too during the analysis and modeling and analysis phase as well as other shortcut key. And if we right click on the working interface, we see the nodes element boundaries, the toolbars and the function bars which we work on Midas. So let me start to model the structure in Midas. So this is the structure I am going to model in Midas in X direction, the grid of 5 meter equal, and Y direction, the grid of 7 meter equal. And here is a core wall or lift wall, and here is another shear wall. The structure is 15 story with a floor height of 3.5 meter. And now let me turn into Midas. In Midas, first of all, let me go to the structure grids, then define the grid lines, give some name, grid A suppose. In X direction, 2 at the rate of 2.5 meter distance and 3 at the rate of 5 meter. 3 at the rate of 5 meter. Okay. And Y grid lines, we can choose either absolute or relative grading. 2 at the rate of 3.5 and 2 at the rate of 7 meter. Click on apply. Okay. Here we see the grid lines. There is some mistake. I can check 20, 21, 5, 10, 20. Okay. So let me zoom in. Let me go to zoom in. Okay. So this is the grid lines. And before creating the nodes, and one main thing we have to understand that for any elements or flat elements or wall element, first of all we have to create the nodes. So before creating the nodes, again I want to define some properties of the material. For example, go to properties. Here we have the material properties. Here time dependent material, plastic, section, inelastic properties, damping and table in properties wizard. For now, for the linear or elastic analysis, I will define only the elastic material properties as well as the sectional properties. So let me go to material, let me go to air. Here we see the material wizard. The material ID is 1. Its program automatically detects, or we can put any name. So let me give concrete grade of M30. Here the elasticity data, the type of design, let me select the concrete, and this is the concrete wizard Indian standard. Here we see the different countries standard. For example, US ASTM means US, New Zealand, Canada, Japanese, British standard, etc. So let me select IS standard. The database concrete grade is, let's suppose, M30. Here we see the properties of concrete, the modulus of elasticity and Poisson's ratio, as well as thermal coefficient and weight density. And for now these things have to be remain the same. So let me add, and let me add M20 concrete also. Here simply select M20. apply, and let me add another M25 concrete. Let me go to M25 concrete and select apply. Then let me go to steel Fe 490. Suppose here still there are also many countries standard. I choose Indian standard. Go to the database. I choose 490. 490. Here we see the modulus of elasticity of the steel. Similarly, the Poisson's ratio, thermal coefficient, and weight density. Although if we choose any of the steel, the mass density is same and the modulus of elasticity is same, and there is an option to put the user value. So the properties are the same. So let me click apply and okay. After this, let me go to section properties. Sectional properties means beams and column section. Let me go to add. Here we see the different selection data for database or user value. Steel reinforced concrete, combined taper sections, composite. For now, let me go to database or user value. Section ID is 1. Go to concrete for RCC. Select solid rectangle. Here we see the solid rectangle and give the name of column 600 by 600, 0.6 meter and 0.6 meter. Here we have set the unit of force in kilonewton and distance in meters. So the unit meter of your shear. Consider shear deformation. Take this, apply, and again column 700 of 700. Go to 700, 0.7 meter. Apply. Okay. Then I go to beam 400 into 700, which is same 0.4. Then beam 350 by 700. Let me define two beams for as a trial section and two columns as a trial section. After the analysis results, this section may be changed. Okay, two column section and two beam section. And let me define another beam, which we call SB, means secondary beam, 300 into 500. 300 into 500 depth. Okay. Then after this, let me go to thickness. Thickness indicates the thickness of slab or plate element and the shear wall element. So let me go to the thickness data here, the value, and another one is stiff. For now, let me go to value. Slab 125 mm thickness. Here the in plane and out of plane thickness is 0.125 meter. Let me click OK. No need to have a flat offset here in our model. And another one is shear wall 350. I put shear wall 350, 0.35, apply, and another shear wall of 400, 0.4. Here I put 400. Okay, here I assign the slab of 125 mm thickness and shear wall of 0.35 mm and 0.4 mm. It is 350 and 400 mm thickness shear wall. So the material definition as well as sectional properties has been assigned or has been defined. After this, let me go to node or element tab. Here we see the nodes, elements, and flat plate structure as well as mesh. First of all, let me create the nodes. In order to model or to draw the or to create the elements, structural elements, we have to create the nodes in Midas Gen. So let me go to create nodes. Here we see the tree menu. In tree menu node, there are so many options for the nodes: create nodes, delete, translate, rotate, etc. Let me go to create nodes. Here let me select this point, this point, this point, this point. The cursor snaps to the intersection of grid lines, and these nodes can be translated into these grid lines. But for now, I'm going to create the nodes for every intersection of the grid lines. Okay, okay. Sorry, no need to draw the nodes there. Here, 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 and here. Okay, this, this, this one, this one, this one. Okay, the nodes has been created, and after this, let me save the structure. Here's Midas practice, Midas practice. So let me go to create the element here. First of all, I want to extrude these nodes into the columns. So let me go to extrude, select all the nodes. So here extrude element, the entry menu, element wizard appears. There are so many options for translating or working on the elements function. So the extrusion type is here node to line elements. And there are other options as well, line element to planar elements and planar elements to solid elements. Line element to planar element means we can draw the shear wall, or we can draw the model the slabs from the beams or column element, which are line element. And for creating the solid element, they can be translated or they can be converted from the or extruded from the planar element. So here the element attribute is beam. There are four options: beam, truss only, beams, tension only members, and compression only members. For the case of beams and column, we have to select the beams. As you know that beams and columns have 6 degrees of freedom in each node. So if we draw or if we extrude it in a vertical direction or z direction, it can be modeled as a column. And if we extrude the node into the horizontal x or y direction, this can be treated or this can be modeled as a beam. So let me select beam. Here the concrete grade, I want to select M30 and column. So the height to be extruded is 3.5 meter. So let me click apply. Okay. So if we see the perspective view or 3D view, there are the columns extruded from the ground or zero level to the first floor. So these two columns are unnecessary, three columns are unnecessary columns. I will delete these columns, and before that let me extrude or let me draw the beam element. For that, these nodes can be these nodes. Suppose let me select one node. This node can be extruded horizontally to either of the direction. Let me uh, translate these nodes here, translate node, and let me go to this direction. This is 5 meter, 5 comma 0 comma 0, and we see, let me select this node and we see what's the problem. So, sorry, the nodes have to be extruded, not translate. So let me extrude the node here. For example, let me select this node. Let me go to perspective view. Let me select this node and extrude it to line element in x direction. Suppose 5 meter, 5 meter, 1, 2, 3, 4, 4 equal distance and number of time is 4. Then let me click OK. So this is the beam element extruded from the node, and we have to select the beam here, but it is column. So let me redo it again. Let me select these nodes, select the beams. Suppose beams are 400 by 700, 4. Okay. So the beams can be extruded from the nodes as well, or we can create simply the by the create element here. Create element columns material is M30, and let's select the section as beam 400 by 700, and here the nodal connectivity. The color screen appears in the place where we have to put or insert the value. So let me connect the nodal here. Go to this nodal and this nodal points. Similarly, this one, and this one, this one. Okay, so the beams have been created. So there is one unnecessary column. I want to delete this column. So here we have the option to delete the column as well. Delete element, select. So let me go to the elevation, delete element. First of all, select and delete this element. So I think this element is also unnecessary column element. I will delete this later. And let me go to the perspective view. So this element is also not necessary. Let me delete. Okay, so I will delete these two columns. This one has also been deleted, which is also not necessary for now. And I will delete these columns after creating the shear walls. And the nodes are also deleted. Here we see the beams and columns has been created, and let me create the shear wall or the core wall. For creating the core wall, let me select, and before creating the shear wall, let me go to top view and model the secondary beam. Like it has here, these red beams indicate the secondary beams. So let me model the secondary beams. So while modeling the secondary beams, this is also similar to model the main beams or columns. So here we see the division of the beam or the grid is 1 by 2, and if we go to the section, we see the cursor is snapping in the mid zone. But if we divide this span into 4, let me select 4, and the snap is moved into the same one-fourth position. So for now there is only one beam. So let me go to draw. Let me go to draw the or create the element. Here let me select secondary beams, go to nodal connectivity. So here the cursor is snapping in mid zone, so I select like this. Okay, and similarly here. Okay, from here also this this and this. So here from here also there is a secondary beam up to this grid. Okay, so after this let me delete these columns. Sorry, only column. So go to 3D view. Oh, here it is snapping in the top and bottom. So let me modify this. Okay, so again let me go to create element, secondary beam snapping. Here and first of all here, from here to here, and again from here to here. Okay, so if you go to the top view, it's okay. So you can delete these columns. Let me select this column. Okay, and delete. Okay, so after this let me draw the shear wall, or let me extrude the shear wall. First of all, let me go to the plane, select these are the extruded view. Let me go to the non-extruded or line view, select the shear walls, these two shear walls, this wall, this wall, sorry, these are the beams and they are extruded, they have to be extruded below the floor level. So let me go to extrude here, line to planar element, go to plate, sorry, here are the four options: plane stress, plate, wall, plane strain, or axial symmetric. Here we are planning to draw or to model a shear wall. So let me select the wall. Let me put the grade of the material or concrete is M30 and I select 400 thickness wall. And here is the option for membrane or plate. As we know that membrane element take only the in-plane forces or in-plane bending. So to consider the effect of in-plane as well as out-of-plane bending behavior, we have to select for the plate element. So let me go to the wall ID. We can put any numbers or any name. So I leave it as usual. It's a translate, it's equal distance. So here in the distance wizard, I'll put minus 3.5 meter. So click on apply. If we see into the 3D, the shear wall has been created. Similarly, we can create or model the slab with the help of the extrude element from line to plane element. Here, the beams are converted into the shear wall. So let me draw again the beam and let me create the beam element again. So first of all, I go to this point. Okay, okay, and here also, this is the main beam. This is the main beam, and this is the secondary beam. Okay, so the shear wall has also been created, and as well as the beams and columns. And here, this is the lift wall. So the one face of the lift wall should be open for the entry and exit purpose. So let me delete this wall. Okay, sorry, the we have deleted the another one. Let me check. Oh, it's okay. So we have to delete this column as well. Let me select this column only. Okay, so this is the shear wall, a lift core wall open on one side for entry and exit purpose. So let me turn on the tree menu too. Here the works which has been performed on these models are shown here. In the structure we have 63 nodes, 87 elements, beams 82, wall 5s. For the properties M30 concrete, 20, 25 grade concrete, Fe 490 has been defined. And for the sections of beams and columns as well as slabs and shear wall. So the properties which are shown here in blue lines, they are not selected for modeling. Only the properties or things with the black lines, they are selected for modeling case. So if we select the column 600 by 600 let me select these columns. These red line indicate the selection of all the columns of 600 and 600. And if we go to the beams, these are the beams, main beams. And if we go to the secondary beams, these are the secondary beams. Here the secondary beams has been deleted. So let me add the secondary beams there. Okay, so these are the secondary beams, and we know we have to translate these elements up to the 15 story. So let me select all the main beams and secondary beam first. Okay, I have select the beams, and let me go to create element. Here we see the translate element. These element have to be translated up to 15 story, the height of 3.5 meter equal distance, and this one is to copy. We can move this element as well. So let me click OK. So the beams for 15 story has been created. Similarly, let me select all the columns and click apply. The columns has also been translated to 15 story, and let me select all the shear walls, and they have to be done the same process. Wall ID increment of up to 15, the ID increment up to 15, or whatever the number we have to put. There are 5 walls, mean we have to say the 5, or no matter any value we have kept here. So we see the structure has been created up to the 15 story. So here, if we look into the depths, some portion of these 2 floors has been removed, and we will do the same after creating the story level. So in Midas, it's very easy to create the story level. For this, after creating these things, let me go to the structure. Here we see the structure type and the wizard, building, coordinate system plan, group, and check structure. First of all, let me go to the control data. Here, if we go to the building control, the base of the building I want to select is use ground level as 0 level. So let me click OK. Then again, let me go to story. Here we have the module name, story name, level, height, floor diaphragm, and Midas Gen automatically generates the story data for the case of wind load and seismic load consideration. So let me click on auto generate story data. Here we see the story data. So let me click OK. But before that, here the 5% tolerance of the flange dimensions has been considered for seismic accidental eccentricity. Similarly, for inclusion of wind eccentricity, 15% of the flange dimensions has been automatically considered in Midas Gen. So let me click OK. Here, if we see the ETFs, I think we have created one more story in Midas Gen. The height is 52.5. So let me turn into Midas Gen. Here is the height is 56. So we have to delete the one story. Here all of story has been created. So let me select this story and click delete. Here if we see the control wizard or story wizard, now there is 52.5 meter, and we can set it as a ground level and edit the story accordingly, but now I left as it is. And one more interesting thing is the flow diaphragm. In Midas Gen, the flow diaphragm has been automatically considered, and if in case of this considered value and the slabs is not modeling, the Midas Gen consider a rigid diaphragm. But if we model the slabs in this structure, we have the option to put to select the do not consider. It means for the case of slab modeling, we have to assign a semi-rigid diaphragm, so that we have to select do not consider. But in this case, the rigid diaphragm has been considered. Similarly, the parameter for wind load analysis and seismic load analysis has been created automatically by the application itself. So let me close this one. So in the top story, let me select the top story first, and here only the selected story is activated like this. So this section have to be removed from the 14 story, and this portion to grid have to be removed from 15 or top story. So let me go to Midas Gen. Let me go to the building. Okay, and here this is the base. Let me select the base only. Base mean base roof structure. Here these things have to be deleted from the roof structure, and from the 15th story So let me go to overall structure. Let me select the 15 story. So from the 15 story, only this portion have to be removed. So let me show the all the structure, and here we see the structure model is same like in ETABS unless the slab is not model here. So this is the overall geometry of the structure. So after doing this, let me go to structure type. Obviously, we know that this is a 3D structure. Here, the types of structure are mentioned. So select the 3D structure, and the mass control parameter is a lump mass. We have to apply the seismic load as well. And another option is here, convert self weight into masses. So here, if the lateral force or seismic force or wind force have to be applied on x, y as well as z direction, vertical direction, we have to select this. And if the lateral force or lateral load have to be applied on both planar direction, and this have to be selected. And if the lateral load have to be applied only on vertical direction, this option is okay. But in most of the case, and in our case, the lateral load can be applied to the planar x and y directions. So choose convert to x and y, and the gravity acceleration is 9.806 meter per second square used in the analysis. Then align the top of the beam section with center line xy line for in panel offset. You can click this and align top of the slab plate section. The slab is not model, so let me click OK. So we see that the lateral loads can be shall be acting like this from x and y axis. So here in the structure type, we have select convert to x and y for the self weight of the structural element. So okay, this is the complete 3D geometry of the structure. After this, we can move to the boundary element. We can move to boundary element as well. So let me go to the boundary element. Here we have the different parameters for boundary element. First one is the support. The second one is the spring support, link, and release or offset, other miscellaneous parameter. So for this case, for the case of linear analysis, now I want to select this bottom portion, and if we see the 3D, all the bottom portion has been selected with one elevation, and we have to define the support or joint resistance at the base of the structure. So let me go to define support. Here we see the deformation in all direction and rotation, restraining rotation in all directions. So the 6 degree of freedom are restrained, or the degree of freedom are restrained against translation in all the three direction and rotation in all the three direction at the base of the structure. So let me click apply. So the boundary condition has been already defined, and in later videos we will discuss about the point spring, surface spring, file spring, and here we have the elastic link, rigid link, and general link. In general link, in the case of nonlinear analysis, the link properties, the properties of viscous damper, viscoelastic damper, steel damper, hysteresis damper, as well as isolator can be modeled with or assigned with the help of this parameter. And the beam in release will release the end of the beams in case of secondary beam, and the beam in offset and the plate in release. So we'll work later on this.